Hey guys, so I decided to make a midterm review guide. And as far as this goes, I'm just going to kind of explain more of the principles of each of these units you're about to see again. If you want to work on the review, I've printed out the reviews. Y'all are working on them. I still think like you will get more out of it working these packets and trying to actually solve what all these problems are. But it might be difficult for you even with the answers to ask like why is it the way that it is. So that's the idea of these videos. These videos should not be the end all be all about what actually like this isn't all you're learning. You need to be able to practice these problems because you won't be able to finish the test in time if you're learning it for the first time in that final exam. So I'm going to start from the beginning. Lap 1, constant velocity. You need to have a strong understanding of constant velocity to do really anything else in physics. So in constant velocity, we are saying an object is moving at the same speed for that duration of time. So here's an example. For every second that goes by, this object goes up a certain amount. So that's what the position time graph would look like. And the velocity time graph will seem really simple too. It's just going to be a flat line. So velocity time, it's pretty straightforward. It's just an object going one speed the entire time. Because there is no sense of change in velocity, that makes the acceleration time graph should be just zero the whole time. So let me just put it's at 0 meters per second squared. So this whole graph is just on the zero. Basically, what we will get out of this is the slope of this graph. So this slope here, slope, which is if you were to solve this, it would be delta x over t. That is equal to velocity. So when I say delta x, what I mean by that? Delta, whenever you have its final minus initial, so it would be final x minus initial x. Final position minus initial position. That's how you get the velocity here. If you take the area underneath this graph, area gets you delta x, and the area is calculated by multiplying the height by the width, velocity times time. Now, it might be a little hard to see, but these are actually the same equations. And essentially, I'll write it out as this. Final x will be equal to velocity times time minus x initial. Sorry, plus x initial. And so what this equation is trying to tell you is that if you want to know how far an object goes, multiply its velocity by time, and then also add in its starting position. A lot of times your starting position is 0, so 0 plus however fast and how long you're going for, that gets you how far you're going to go. Most constant velocity equations are pretty straightforward, like problems are pretty straightforward for it, so I'm not too worried about how y'all are going to manage with that. I'm just going to write out some terms though, just so we're all clear. So the first term I want to talk about is speed. And speed is how fast you will be going according to the path taken. And what I mean by that is, and I'll zoom in here, so essentially speed is equal to distance over time. And distance is actual path taken. Distance is a scalar term. Because distance is a scalar, so is speed. The other two variables that we've been talking about in this unit when I'm talking about this stuff is, so the first one I'll talk about is velocity. How fast you go the shortest possible path possible. And displacement is fastest path possible. All right. So what this ends up being is that, if you're solving a problem, speed will be equal to distance over time. And velocity will be equal to displacement over time. Now, when you're solving these problems in the packets, like what we've been doing before, I'll just show you some examples. When you take the time is always the same for both of these objects. I'll go to this object here. So this is an object that's doing multiple motions. Yes, it's constant velocity when it's moving, but you see constant 4 meters per second, but then it switches to negative 3 meters per second, then it's not moving. So when I'm calculating the speed and the velocity, even these 2 seconds that it's not moving, I have to count it into my running total when they ask me from 0 to 5 seconds, what is my speed? So even if it's not moving, you have to keep those into account. Distance, the way I'd find the distance for this object, I have to find the exact path it went. So it goes up 4, another 4, it goes down 3. I add them all up. That's 11 meters plus 0 plus 0. Displacement, if you go backwards, that counts into it. So you go 4 plus 4 minus 3. So that means you've only gone 5 meters. And I can see here the shortest possible path. Instead of going all the way up and down here, I could have just gone this way. All right. So I think I'm going to end it there. I think I'm going to split these videos up so they're not too long. And I'll continue with lap 2 next.